Hey everybody, let's do the finals review for Honors Algebra 1. There's this many questions, and also keep in mind, I'm going to keep a running list over here of things I mention. And I say that because I know one of the questions here, and just something I've heard people mention like throughout the day today is, I forgot what this is. And that happens, so here we go. Which of the following expressions are third degree binomials? Third degree is a thing. Binomial means two terms. So right away, this is a bad answer because it's 1, 2, 3 terms. This one is a good answer because it is a binomial, 1, 2 terms. And the degree here, this is 2. That has an invisible 1. That's 1 and 1. So this guy has a degree of 2. This guy has a degree of 3. So that's why it's B. And then how about C? C is a binomial because it's 2 terms, but that has a degree of 7, so that's no good. And then this one, binomial, and this has a degree of 3, so it is also that one. So zooming out just so it's clear, B and D, because we select all that apply. Here's our first, what was that again? Point slope form is y minus y1 equals the slope times x minus x1. And here is it on the things I've mentioned. All right, what is an equation in point slope form of the line that passes through the point? There's our x, there's our y. It has a slope of -4. I love these because it's basically like this. Y minus 10, because that's our y, equals the slope of -4 times x minus -2. So you could literally leave it like this. If you want to simplify it, about the only thing I might simplify is change that to a plus sign. Otherwise, we're good. Write this using rational exponents. It is simply 10 to the 1/3 power. This index right here, if it was a regular square root, the index is invisible, and it would be 10 to the 1/2 power. If we had a 4th root, it would be 10 to the 1/4 power. I think you get it. Rewrite the expression where x is positive without a perfect square factor in the radicand. That sounds awful. Like if I were to just have you read this without any context, I would personally be upset alongside of you, right? But really all we're going to do is multiply these two and simplify it. So 2 is multiplying nothing out front. 6 is multiplying 18. So let's see, 18 times 6, that's 60 plus 48, that's 108. So the square root of 108. X to the 3rd times x to the 5th is x to the 8th. And let's see, we are now going to take the square root of 108. So 108 is really 2 and 54. That's 2 and 27. That's 3 times 9. That's 3 times 3. So check it out. We have a perfect square here, a perfect square here, and he stays home. So let's see. This 2 goes out, like I was just saying, 3 goes out. So there's already a 2 out here. So it's now 2 times 2 times 3 because of this 2 and this 3. And then this guy, he's a perfect square also. X to the 8th is x to the 4th times x to the 4th. And who's left at home? 3. And if you're like, wait, 3? Yeah, this 3. So now our final answer, 2 times 2 is 4 times 3 is 12. There it is. Sasha sells t-shirts each day. She earns a set amount plus a commission. Write a linear function f to determine Sasha's pay. So let's see. This is x, and this is y, because her pay is going to be dependent upon how many shirts she sells. So the idea is if we write a function f to determine the pay, we could call it f of t if we wanted to. We could call it f of x. It really doesn't matter. So here, let's just go with f of t. Why not? So instead of x, it's t. All right. So this table is going up 1, up 1, up 1. I think you see it. This bottom part down here is not going up by 1. It's going up by 3s. So plus 3, plus 3, plus 3, right? What that means is it's a change in 3 over 1. That means our slope is 3. So not 3x, 3t, right? Now we need the y-intercept, which I'm sure we could go over here and use the point slope formula, but you know what? I'm just going to get like creative here and be like, the y-intercept happens when x is 0. So if I go down 1 to 0, that means I'd have to go down 3 to $65. So boom, I'm done. Here's a function for that linear equation. That's about it. What is the solution of the system of equations? Well, we have 3 ways of solving a system. In fact, here, I'll zoom out over here. We got 3 ways to solve a system. 3 ways to solve a system. And I'm like, instead of pausing and just writing this automatically, I'm going to see if you can like figure it out as I do it. So number 1 is you can just graph them and you see where they cross. Number 2 is to do substitution. Number 3 is to do elimination. Maybe that sounds familiar, maybe not. So this one, I don't want to do the graphing. Why? Well, because one, that's the y-intercept, and I'm looking at the x and y-intercept for this, and they're not going to be pretty either. So no graphing for me. They're not in a great spot to do elimination, but since this is already solved for y, I'm going to do substitution. Again, it's not the prettiest substitution in the world, because here's what it's going to look like. This red thing is what's going to go there. Negative 3 over 2x plus 5/4. Not real pretty, right? But not that crazy. We're going to distribute this 8. And we get negative 2x minus. Now, I'm going to kind of do this a little in my head. 8 divided by 2 is 4. 4 times 3 is 12. Okay, so there's that one, taking care of that one. 8 times 5 is 40. 40 divided by 4 is 10. And that equals negative 25. So you can see I wasn't that crazy, right? These are like terms. I'm going to go ahead and subtract 10. And then, unfortunately, yes, I'm doing the problem right. I double-checked all my math on this because this is the second time I'm working all these problems. I made sure I got every problem right, and then I'm now doing them with you. So there's x. Cool. So then I'm going to plug that x in right here because I can easily find y there. And if you're like, easily, yeah, right. Okay, well, I understand. Y equals negative 3 over 2 times 35/14 plus 5/4. Cool. So we can multiply these and we get y equals negative 105/28 plus 5/4. I can multiply that by 7 over 7 to get y equals negative 105. Hang on, let me pretty that up a little bit. Negative 105/28 plus 35/28. That gives me negative 70/28, which reduces to negative 5 over 2. Y equals negative 5 over 2. So really our x was uglier than our y in this situation. But there we go. And if you were like, I don't believe it, you can plug those in yourself and find out. And it does work. What's the value of x in this equation? I'm just going to solve for x. I'm going to distribute this 3 to get 6x minus 15 minus 4x plus 8. On the left side, there's some like terms. There's some like terms. I'm going to add 7 and divide by 2. x3. Find the value of c that makes this a perfect square trinomial. We're going to be completing the square. So we're going to take b divided by 2 and square it. So you might think, what? We're going to do 35 squared because that's 70 over 2 squared. So yeah, you could just technically say c equals 35 squared, or you could multiply that, and there you go. Listing all the possible values of k, if k is greater than 0, we have been doing this x thing, so it would be a times c, which is just k in this scenario, because k is actually a number and a is 1. And then b is going to be 10. And so the idea is that it's what type of factors could possibly combine to make 10. Well, there's only so many. In fact, this is it. So imagine that these were factors. Well, then that would be 9, because 1 times 9, and 2 times 8, and 3 times 7, and 4 times 6, and 5 times 5. So your answers for what are the possibilities of k are these answers right here. What is the graph of 4x plus 8y equals 16? Well, I used to hate standard form because this is standard form. In fact, I'll probably add that to our list over here. There it is, standard form of a linear equation. Ax plus by equals c. A and b are going to be whole numbers, and you want a to be positive, generally speaking. So back to me saying I used to hate doing this, but now I have this little goofy way of doing it. I call it the slap, because this is good for finding x and y intercepts. So the x and y intercepts happen, well, when x is the intercept, y equals 0. And when y is the intercept, x equals 0. So I call it the slap because what I'll do is, if I want to find the y-intercept, imagine I have a hand. I usually have, here, change my pointer to a hand. I'll slap this, and I literally will just cover it with my finger. I've covered it with green right now. And then I solve this equation. So 8y equals 16. Well, that is when y equals 2. And I'll erase this. And now I will pretend to slap the y. When does 4x equal 16? When x equals 4. And you see how easy it is to graph that when you don't have to worry about like finding the x and y intercept, or I'm sorry, when you don't have to worry about putting it in slope intercept form. So there's that. Write this in standard form. So easy. You find the guy with the biggest exponent. You write him first. Then you go next. It's 3x cubed. Next, negative x squared. Next, and next. So easy. Solve this equation. I did this 2 ways if you were to see my paper. One way is, well, actually, I guess technically I do it one way, but there's a couple of different approaches. You cannot get these to equal each other unless they're the base numbers, the ones I've just underlined, are equal to each other. So 64 is 4 to the 3rd power, and 16 is 4 to the 2nd power. So what happens is the exponent didn't change at all. And now we have a power raised to a power. You multiply the powers. So yeah, 3 times 2x, 6x, 3 times 4, 12, 2 times 5x, 10x. And now you basically ignore the bases, because the only way these can actually be equal to each other is if the exponents are equal to each other. So you do that and you get that x equals 3. So if you're wondering, just out of curiosity, what's the other approach I took? 64 is 2 to the 6th power. And 16 is 2 to the 4th power. And it does work the same way. you would get 12x plus 24 equals 20x. You subtract 12x, you divide by 8, and you get x is 3. What is the equation in standard form of a line? Well, I wrote it a second ago. ax plus by equals c. And so if you'll notice, that means the x and the y are on one side. Well, we have a y over there and an x over there, so that will not do. And also I said that a and b need to be whole numbers. So here's what I'm going to do. I'm going to multiply both sides of the equation by 2. So I get 2y minus 10 equals 3 times x plus 6. This is now 2y minus 10 equals 3x plus 18. I'm actually going to keep my x here, so it's negative 28 equals 3x minus 2y, and that's it. Before you freak out that there is a giant word problem, just relax. 2 schools planned a trip. School A filled 6 vans, and 5 buses with a total of 348. So stop right there. Totals are where we write equals, okay? So that's why I like problems like this, because they tell us we got 6 of something and 5 of a different thing. And you guys are totally capable of doing stuff like this. All right, so that's scenario A. Scenario B, where are you at? B, 3 vans, 10 buses, 624 students. This is a system of equations. I could do a graph, I could substitute, I could eliminate. I'm going to do elimination because I love to do elimination. It's so easy. I'm going to multiply the bottom equation by negative 2 because I'm going to cancel out my v's. So I get negative 6v on bottom minus 20b equals negative 1248. And if you're like, I can't believe it, that's so much, just relax. In fact, here's what I'm going to do. I'm going to erase this and just add all that together. Okay, here we go. Erasing, done. So 6v and negative 6v is gone. 5b and negative 20b is negative 15b. 348 minus 1248, negative 900. Divide both sides by negative 15 and you get the b equals 60. So it sounds like there are 60 kids on a bus. That's a lot of kids on a bus. But then we can take that and we can plug it in right here, and we will find that there are 8 kiddos in a van. Not that crazy. I mean, well, maybe if you're on the bus, but anyway. Simplify, write your answer in standard form. All we're doing is adding. So 3x cubed and 4x cubed. That's 7x cubed. Done, done. This guy is the next in standard form order. So I'm going to go ahead and write him. Done with him. He has no like terms over here. And then we have 7x plus negative 11x. That's negative 4x. And then let's see. Negative 1 plus 1 is nothing. So we are done with that one. Next is a problem that I am going to skip. If you would like to see me work it, you can ask, but I'm just going to skip it. Next, what is the factored form of this? Let's do the x. We got 1 times negative 24. That's negative 24, and we want to get negative 2. So I believe that is negative 6 and positive 4. So we're going to get x minus 6y times x plus 4y. How come y? Because of that y. Find the value of x in this equation. Just like a previous problem, I'm going to multiply to get rid of my fractions right away. And one reason I'm doing this is because I'm pretty sure you could do this the long way, but also if you're watching this, then you get a little special treat of like, hey, that is useful. So this 4 is going to multiply here and here, and then I'm doing it over here too, and it's only going to multiply here. Now, if you don't know why, let me give you an easier version. What if I had 4 times 2 plus 3. Actually, let's make it a little more like what we've got. What if I had 4 times 2 times 3 plus, I'll just do 4 so that it's kind of in that order. Well, you could do the inside, which would be 4 times 6 plus 4, which is 4 times 10, which is 40, right? Or you could do this. 4 times this, that's 4 times 2 times 3. And 4 times 4, which is plus 4 times 4. So this is 8 times 3 is 24, and 4 times 4 is 16. What's 24 plus 16? It's 40. So this is what's happening right here, okay? So what we're going to get is 3 times 6 plus 1 minus 12x equals 2x minus 1. The 4's cancel here. Now, these 4's cancel each other, but I cannot forget to still multiply that by 4. So if you already are seeing like the value in doing that, cool. If not, sorry. So now I'm still going to distribute this 3 here. So I get 18x plus 3 minus 12x equals 2x minus 1. Zooming in here. 18x and negative 12x, that's 6x plus 3 equals 2x minus 1. I'm going to subtract 2x. I'm going to subtract 3, and I get x is negative 1. What's the solution of the system? Well, I could graph, I could substitute, I could use elimination. I like elimination here because I can just multiply this by negative 2 and then add it to the top equation. Gone. 5y minus 6y is negative y. 14 minus 32 is negative 18. So y equals 18. Take that, plug it in. So I'm going to get x plus 3 times 18 equals 16. Oops, that's not equals, not quite ready for that yet. 3 times 18 is 54. And when I subtract 54, I get negative 38. This is a classic example of why you wouldn't want to graph this, because the equations would take kind of forever to cross. So, I mean, you could still do it, but that's rough. Simplifying this is way easier than you might think because of mom. Mom's down here. She's the greatest common factor. We can factor a 5 out of the bottom. And then what we have is the top factors cancel, and you just get 1/5. If you're not sure why you're able to do this, imagine that you had this. 2 over 2 times 3 is really 2 over 6, which can be reduced to 1/3. Well, what is it that you did here? You divided by 2, right? So if you were to divide by 2 here, that's 1. And if you divide by 2 here, that's 1, leaving you with 1/3. So that's why it's 1/5. Tickets are sold for a choral performance on the first day. Ticket sales of the school sold 7 adult tickets. So let's see, we got 7 adult tickets and 12 children tickets for a total of $127. School took in $152 on the second day by selling 11 adult tickets and 3 child tickets. What was the price of each ticket? Well, system of equations. Pretty much the only system of equations we really did that you really had to write the equation, which is why I've been so it's no big deal because we can do this. So what I'm going to do is multiply this bottom equation by negative 4. I get negative 44a minus 12c and negative 608. Fun. 7a and negative 44a. Let's see, that's 37a, negative 37a. 12c and negative 12c, those cancel. 127 minus 608 is negative 481. You might think, holy cow, this is insane. A just equals 13. You take that 13 and you're going to plug it in. So I'm going to plug it in here just because I can do 11 times 13 kind of in my head. And if you're like, how can you do that? It's 130 plus 13. So that's 143 plus 3c equals 152. 3c, when I subtract that, is 9. So a child's ticket was $3. Graph this inequality. It's in this form. This form, slope-intercept form, y equals mx plus b, which means that this is my y-intercept. So 1, 2, 3, y-intercept. My slope is 3, so I can just go rise 3, run 1. And I also like to rise in the other direction, so 1, 2, 3, 1, like that. This is an inequality, so I need a dashed line. And then I am going to be shading on the greater than side, which I will tell you is this side. But if you weren't sure which side it was, you could plug in a test point. And in fact, what's a test point? I feel like I remember us talking about that. A test point is like 0, 0. You pick something that's definitely not on the line, and you plug it in. So is 0 greater than, here, I'll do it here. 0 greater than 0 plus 3? Well, no, 0 is not greater than 3. So it fails over here. Fails. And we don't shade on the failure side. So that's why that one's done. Which of the following is an arithmetic sequence? And at first this might freak you out because you're like, what? I don't remember how to do that. Just relax. This is going up by 2, and then by 3, and then by 4, and then by 5. That did not have a common difference, and that's why it's not an arithmetic sequence. This one is going down 3, down 3, down 3, down 3. I like it. It has a common difference. Divided by 2, divided by 2, divided by 2, divided by 2. This one is actually a geometric sequence because it has a common ratio, but that's not arithmetic, so see you later. And then this one is literally just adding the next digit, like from the counting numbers that would be next, so that's why it's 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, so no, see ya. Solve the equation using the quadratic function or formula. There it is. And here is this, in case you need to know it. So, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alrighty, negative 28 plus or minus the square root of, I'm definitely using a calculator to do 28 squared minus 4 times 1 times 3. It's 772, which is fine until you realize it's a bummer of a square root because it only ends up being this, watch. It is 2 times the square root of 193. Isn't that crazy? So then your final answer is, believe it or not, negative 14 plus or minus the square root of 193. If you want a decimal, it's negative 0.108 and negative 27.892. So I went ahead and added the quadratic formula to our table here, but don't worry, you're going to be given the quadratic formula, so no big deal. Linear, quadratic, or exponential equations based off the table. Well, linear's got a common difference we mentioned over here, and quadratic has a first difference that will vary and a common second difference, but we didn't really talk about that ever, so don't worry about it. And then exponential is going to have a common ratio in the range. So how you figure this out is basically you go from x to x to x, y to y to y, and tell what happened. So for our x's here, pretty clearly they're going up by 1, right? For our y's, they're going up by half, and then by 1, and then by 2. But you know what? We can look at that a different way. What if they're actually doubling each time, right? Half doubled is 1, double that's 2, double that's 4. So that means that this is an exponential function because it has a common ratio of 2, okay? And that's in the range specifically. So you could actually look at this and tell the equation just by looking at it, because it's the starting amount, which is 0.5. And in fact, what's the starting amount? It's when x is 0. And then it's times 2 to the x power, because our common ratio is 2. So if you don't remember that, well, there's a little trip down memory lane. Let's check out this next one. So the x's, looks like they're going down by 2 each time. Down 2, down 2, down 2. And the y's are going up by 1. Okay? So this is linear because we have a slope. It is negative 1/2. And I guess technically it has a common difference as well. You don't have to worry about, again, writing the equation. And in fact, I'm not going to write the whole equation here. I'm going to start with our slope because, like I said, it's negative 1/2 because of like rise over run, that y over x. And then using this particular table would be a little annoying to find the y-intercept. But we could definitely do that if we were to go look at like our point slope form. Remember that? Point slope form, because we definitely have a point and we definitely have a slope, right? All right, now we're going to be finding the product of these two. Easy peasy. We're just going to distribute. So 4x squared times x squared, 4x squared times negative 3x, 4x squared times 8. So we have 4x to the 4th. We're going to have negative 12x cubed and 32x squared. Now we're done with that. So we're going to distribute our 6 now. 6x squared minus 18x plus 48. Add all that up. 4x to the 4th minus 12x cubed plus 38x squared minus 18x plus 48. That's it. What is the value of x in the diagram below? This is Pythagorean theorem. Pythagorean theorem looks like this. And our c is right here, so we can go and write that x plus 2 squared. That's a squared, I promise. And then we have 8 squared plus x squared. Those are our other legs. And what we're going to get is 64 plus x squared equals x squared plus 4x plus 4. Just trust me, that when you expand that, that's what you get. I'm going to subtract x squared, and notice they cancel. I get 64 equals 4x plus 4. 60 equals 4x. X just equals 15. So here is Pythagorean theorem. It works with right triangles. Here's a right triangle. It's a squared plus b squared equals c squared, where a and b are the legs. It does not matter the order you write them in. And then the hypotenuse, that's what that hype means. Hypotenuse is c. And c is always the longest side, and the longest side is always opposite the 90-degree angle. Each day at the bakery, Jack bakes cakes and helps out at the counter. Make a scatter plot of the hours Jack spent at the counter as a function of the number of cakes that he bakes. Draw a trend line. So what's interesting about this is, based off how it's written, cakes is actually the x and time is the h. Oftentimes, when you do this stuff, time is your x variable because you work a certain amount of hours and you get a certain amount of pay. Not in this situation. The time is the y. So here's what I'm going to do. 1, 2, 3, 4, and then 5 just for fun. 1, 2, 3, 4, 5, and this is time. And then on the right side, the x-axis, 1, 2, 3, 4, 5, 6, 7, 8. 8, that's cakes. So we have 2, 4, 3, 4, 5, 1.5, 6, 2.5, 7, 1.5. And we are supposed to draw a trend line. So I may have cheated and used Desmos and came up with like the perfect one. But you don't have to do that. I will just tell you, it looks something like this-ish. And you can see how that's not bad. It could be a little lower, but that's the idea. A trend line would look something like that. If you did this, you're wrong. You know what I mean? So that's the point, is don't go so crazy. So check it out. That is halfway through this. So we're going to call this video number 1. Let's see if you watch video number 2.